Hey everyone, welcome to Studio Review. It's Kyle, and this is the start of the series where we're going to be going into depth about what we are supposed to do within these studios and go over concepts that we needed to complete them. In this video, we're going to be covering area of a circle. The goals of this studio were to learn the basics of IntelliJ and those Java packages, as well as creating classes and understanding variables, then using methods to compute the area of a circle. Our first task was to make sure that we forked the repository Java Web Dev Exercises. We go to the Launch Code Education GitHub using the URL provided. Then on this page, we're going to make sure we're in the correct repository. Once we confirm that, we click on this button Fork. This is going to copy this repository from the Launch Code GitHub into our GitHub, meaning it's a completely new separate code base that we can work with. Great, it looks like it copied over. We then go over here and click Code. We need to clone it. We copy this link, and then we go into a new bash terminal. Once we're in our new bash terminal, we need to type in git clone, and then paste that link that we copied from our repository. We press enter, and it clones it into our directory. I see that I cloned it into my lcgits directory. Next, we need to open this project into an IntelliJ. Let's make sure that we have the correct one downloaded. Our instructions in the text told us to download the IntelliJ IDEA community version. Looking at the IntelliJ website, we see that we have two options when trying to download: Ultimate and Community. We need to make sure that we downloaded Community. Once IntelliJ is downloaded, we want to open it up and select Open or Import. Find the directory we cloned our repository, select that folder, and press Open. Once the project is open, we can go in and we see that we have all of our folders, including our very important source folder. So great, let's move on. So now let's go ahead and create our first package. We're told to create the org.launchcode.java.studios.area_circle package. But what does this mean? To some of us, it might look like just a bunch of jumbled words, but it's actually giving us a lot of information in one name. So let's go through this and break it down. Starting with org, this means organization. We're creating this package for an organization. We can also use com for commercial, like Google, or we could use edu for an educational entity, like a college or university. Next is the name of the organization or the name of the company. In this case, self-explanatory, launch code. After that, we need to answer the question, what language are we going to be developing in? In this case, Java. After that, we provide a little bit more context. Inside of the organization launch code with Java, we're going to be creating a studio. Finally, what's the name of our studio or the name of our project? Area of a circle. That's what this package name is telling us. So let's go ahead and create it now. To add that package, we go up to our source folder, we right click, we say new, package. We type in org.launchcode.java.studios.area of a circle. Press enter, and our package is created. We know in IntelliJ the difference between a package and a folder because a package has this dot in the middle of it, while a folder has no dot. So what are packages? They're a special kind of folder that tell our compiler where our code lives, or what we need to build our application or program. This includes classes, which leads us to our next step, creating our first class called area. When creating a class, we need to keep three things in mind. The first being declare your static and class variables at the top. A quick example of that is if we have a class called myClassName and we want to create one of these class variables, we always start with the keyword private. This is because we don't want these variables to be accessed outside of the class. Next, we say what kind of variable it's going to be, which is string, and then the name of the variable, which is a random word that's set to cookie. When we create this class variable, that again means multiple methods can access this variable within their own code. So what do we mean by this? That if we create a first method and a second method, both of these methods can access a random word using the keyword this. The second thing we need to keep in mind, always create at least one constructor within your classes. Again, if we have myClassName, we need to make sure that we're declaring our constructors. So we use that keyword public, and then the name of the class, which is myNewClass, then open and close parentheses. Now within these constructors, we can also do things like set values of our class variables. For example, if we bring back in a random word, we can set a random word equal to cookie via our constructor using the keyword this. Additionally, we know that in Java, we can have multiple constructors. So in that case, we can create another constructor below it that actually takes in a past random word as a parameter, and we can set the class variable, a random word, to that provided parameter, which is past random word. Finally, we need to make sure that we're creating our methods at the bottom. Going back to our example, if we have our class variable, a random word at the top, then our constructor next, we can create other methods below this. In this case, we can create a getter for a random word called getRandomWord. This retrieves that class variable and returns it outside of the class. This is how class variables should be accessed from external classes. But how do we set it? In that case, we're going to create another method called setRandomWord, where we'll take in a new random word and set that class variable to what was ever passed. We can also place more methods at the bottom. So now let's look at our task. We need to ask the user for a radius, calculate its area, and then print the result. Let's take what we've learned about classes and do this now in IntelliJ. So to do this, we go up to the package we just created, find where we want to add that class, right-click, press New, then click on Java class, then type in area and press Enter. This creates our area class. We're then met by this pop-up that says, do you want to add the following to get? It's asking us, do we want to add the file or the class area that we just created to our get when we push? I want to see this file later, so I'm going to click Add. And there we go. Before we start actually completing this task, let's dissect what this task just asked us. It's asking us for three things. The first is to ask the user for the radius, so we can calculate the area. The second is to calculate the area. Finally, we need to print the result, or our area, to the screen. Great, now that we understand what this task is asking us, let's start creating our class area. Like we just talked about previously, we need to keep those three things in mind. First, we need to declare any class variables at the top. We have no class variables just yet, so we'll leave this section blank. The second thing we need to do is to create the constructor. To do that, we use the public keyword, and then when we create a constructor, we use the name of the class, which in this case is area with a capital A. We're going to put open and close parentheses because we don't need to take in any parameters just yet into our constructor. Then we use those curly brackets to complete it. Finally, we need to create all other methods. Here's where we're going to start completing this task. We're going to create a method that asks for that user's radius, calculates the area, and then prints the result to the screen. To do this, we need to start by creating that method. I'm going to say public because I might want this method to be accessible to other classes in the future. Then, looking at our task, it doesn't ask us to return anything. If we don't return anything, we use that keyword void. And then finally, we need to name the method. In this case, I'm going to name it calculate area, and then open and close parentheses, because again, we're not taking in any parameters. Then we put the opening and closing curly bracket, and we've created our method. Now let's start exploring our task. The first thing is to ask for the radius. In order to do this, we need to create something that takes in user input. If we look back into our reading, to receive input from our user, we use the class scanner. Scanner takes input from the user, so I'm going to call it input, and then we're going to have to declare a new class of the scanner, so therefore I use that keyword new, scanner again, then scanner requires the parameter system.in to tell our application that we need to take input from the user, then semicolon at the end. When we create this line, we see that we're getting red text or an error with scanner. If we move our mouse cursor over it, we see cannot resolve symbol scanner. When we see this error, that means it has not been imported into our area class. And if we look at the very bottom, it says import class here. IntelliJ wants to help us. So we go ahead and click this option. And as we see, it imports java.util.scanner. So now we can use it. If we recall our reading, we know that the scanner class has many different methods to take in many different types of user input. Some of these types can be strings, characters, integers, or doubles. So the question we need to ask now, what is the type or data type of radius? We're given the example of a radius of 2.5. From our previous reading, we know these are some data types that we can use in Java: string, char, int, and double. Strings use double quotes, like my dog or pizza. Characters use those single quotes and can only contain one character, like T, M, 1, or an @ sign. Neither of these are very good for containing a number. So let's look at int. Examples can be 14 or a very large number. But the shortcomings of integers is that it can't save decimals. 1.4 or 2.5 cannot be an integer because they have to be whole numbers. So let's move on to double. Doubles can be 1.25, 15.0, or any other wide variety of numbers with decimal points. Because we know doubles can contain decimal points and our given example is 2.5, I'm going to select double in this example to save our radius and our area. I want to make a side note that you could also use floats, but in this example, I am going to be just using double. Now that we know that our radius is going to be a double, we're going to revisit the scanner variable input and ask our user for a double, aka the radius. To do that, we do input.nextDouble. When our user enters a double, this method is going to return us back that double. So therefore, if it returns us back a double, we need to have something there to catch it or remember it. So therefore, we create a variable that will be of type double, and we'll call it myUsersRadius. So now we're receiving our user's radius once they type it into our terminal. Perfect. So the next thing we have to do is calculate that area. They told us that area equals pi times radius times radius. So that means area is going to be pi, which is 3.14, times our radius, which we ask ourselves, where's our radius stored again? And we know that it's in my user's radius. So we say my user's radius. And once again, we need to multiply by the radius again. Once we have our expression written here, or our mathematical equation to calculate our area, we need to save our area into a variable. Our radius was of type double. Our area could have a decimal in it, therefore also being a double. So we're going to create this variable as a double and call it area. Finally, we need to print the result. In Java, to print something out to the terminal, we use system.out.println, and then we supply what we want to print out to the screen. In this case, it's area. Great. Now we're doing all three parts of our task. But as we can see, we don't have anything to start out our program. We want to run our Java program. But Java programs need a starting point. They need a main method. So let's go ahead and find a place to put main. One place that sticks out is at the top of area. This is technically one place we can put our starting point. We type out public static void main, since we know that is the starting point for our Java application. And then inside of these curly brackets, we place what we want to run here. In this case, we want the method calculate area within the area class to run. If we want a method within a class to run, we need to create a new instance of that class. So if you're asking yourself, why did I just have to create a new instance of this class here when I'm already inside of the class? Remember that when you're in the main, you're in a static method, meaning that the keyword this or access to any part of the class won't work. Static doesn't let us do that. So we say area.calculate area. This is going to call to our class method now. So let's go ahead and test it out. We're going to run our area.main. We see that our terminal pops up with nothing on the bottom. This is because our machine is waiting for us to provide input. So just like our example, we're going to say 2.5, and then I'm going to press enter. We see that 19.625 is printed out, and then the process finished. This is exactly what we should see. Finally, we need to create the class circle and include a few methods to do some of the mathematics that we were doing in area previously for us in this new class. So just like last time, we're going to come up here to our package, right-click, press new, Java class, and type in circle. I want to see it in my get when we do push, and therefore I'm going to press add again. In this task, it's asking us to do three things. The first is to create a method called getArea. The second is to take in a parameter radius that is a double. Finally, we need to calculate and return the area. So first things first, we need to remember the three things we do while we're creating a class. First, we check if we need any class variables. We have none right now, so we can leave this blank. The second is to create a constructor. In this case, we use that public keyword, then circle, and open and close parentheses, since we have no parameters or no code we need to put inside of this constructor at this time. Then finally, we need to create our methods. In this one, it gives us the code to complete this task. First, we need to create the getArea method, which will be a static method. So we use the keyword public, the keyword static, since again, it has to be a static method, what it needs to return, when in this case, it needs to be a double, so we say double, then the name of the method, getArea. The second thing we need to do is take in a radius that is a double as a parameter. When we put in parameters inside of our methods in Java, we need to define what they are. So we say double first, and then radius. Open and close curly brackets. Then finally, we need to return the area. So we use the keyword return, since we know we're going to return something, and then we put the area expression, which again is pi times radius times radius. Pi is 3.14, as told to us in the book, times our radius. Where's our radius at? It's the parameter that was passed in. Therefore, we say radius here, then times radius again. Now what it wants us to do is go back to area and replace our original expression with this new static method we just created, getArea. So we go back to the area class. So we need to locate the expression we need to replace, find it, which is here. We know we need to replace this because circles.getArea does this calculation for us. It's its main reason for existing. So that's what we do with circle.getArea. And now inside the parameters, it's asking for a radius. We know that we gathered that radius previously up here and saved it into this variable, myUsersRadius. So we pass that variable into the method. Now we're using circles class getArea. Now, why could we call just directly to getArea from circle and we didn't have to create a new circle instance? It's because getArea is static. And when it's static, we don't have to create a new instance of the class to access it. We can just access it directly. So moving back to calculate area method, we're going to test this out. We'll run it again, and then we're going to type in 2.5 once more. And we see that we're still getting back 19.625. One last thing we need to do is that when we open a scanner, we need to make sure that we close it as well. To do that, we'd put input, which is the variable name of scanner, and then type close. And there we go. Awesome job, everyone. We did this first studio together. I hope everyone really understood the concepts here and were able to complete it on their own. Feel free to reach out with any questions. Next up are our bonus missions. In our bonus missions, we have our first task, which is to add some validation. Some of the questions proposed were, what if the user enters a negative number when we're trying to calculate that radius? A negative number is not correct because we can't have a negative radius of a circle. That's not going to give us a correct answer. So we need to tell them, hey, there's something wrong here. So let's get started. We're going to run it, and we're going to put in a negative number. In this case, we'll put negative 2.5. When we press enter, we get back 19.625. In math, when we supply a negative radius, this is impossible. We can't have a circle that's in on itself. Therefore, this is not valid input. So we need to tell the user they can't type a negative number in our application. So let's do that now. What we need to do, when myUsersRadius comes in, we need to check if it's a negative number. If it is a negative number, we need to print an error out to the screen. If it is not a negative number, we should continue our process as normal. So this kind of sounds like a conditional. If our myUsersRadius is less than 0, aka a negative number, then I need to print an error out to our user. If it is not a negative number, we continue business as normal. There we go. This if statement is checking if it is a negative number. The first thing we need to do in this conditional is print an error to the user. We do this by typing system.out.println and then our error. Otherwise, we continue as normal. If it was not a negative number, continue as normal means we need to calculate the area, meaning we need this double area with the circle.getArea and then printing out our results. So we're going to cut that and paste that into our else statement. But why did we not include the input.close? That's because our scanner input is outside of our if statement. No matter what case executes, whether it's a negative number or not a negative number, our scanner still needs to close. So we keep this outside of the conditional. So let's go ahead and try this. We're going to type in negative 2.5 once more. And now we see we get back, you cannot enter a negative number. Awesome, it looks like our first ask is completed. Next, what if the user enters a non-numeric number, such as a character or string? We can't calculate the radius of a dog or another kind of string. So we need to tell the user once again, there's something wrong with your input. We'll run this again and do an example. In here, I'll put ABC, a non-numeric character. And we see that we get back this error, input mismatch exception. Input mismatch exception means that when we typed in ABC, it had no idea what it was because it was looking for a double. So to get around this, we need to be able to try to get the next double from the user. And if we don't, we have to catch that error and tell the user it was unable to find a double in their input and then print out an error. To do this, we use the try catch. The try catch attempts to execute code within the try statement, and if it fails, executes the catch statement. So let's take a closer look at that. We needed to try to get myUsersRadius. So we place this entire code block within the try statement, and then if it fails, the catch block gets executed. So we create the catch block with an exception in its parameters. This exception here is the actual error that occurred. When we do supply ABC again into our input, the exception here would technically be that input mismatch exception that we got below in our terminal prior. So down here is when that error occurs, we know that our input was not numeric. So we need to again print out an error to our user. So we'll say system.out.println. We'll say you must provide a numeric input. So let's go ahead and run this. We're going to type in ABC again. And now it says you must provide a numeric input, which tells us our catch block is executing properly. Awesome. Finally, what if the user enters an empty string? We're going to run this, and we're going to provide an empty string in here. If I press space a few times and I press enter, we see that nothing's happening. This is because we have not provided any input. If I press space 1.5, that's when we get an output. So to answer this question, it's working properly when we're given an empty string. We don't have to add anything to our code for it to work, because adding those empty strings or empty spaces is ignored by the scanner. Great, let's move on. Our final task is to reprompt the user on negative numbers using while or do while loops. This means when the user enters a negative number, we need to know that it's not correct and then cause our program to re-loop back to the top to reprompt the user for a correct entry. So let's do that. We know that if a negative number is inserted here, it's valid input, so an error won't occur, but it will be checked by this if statement here. If my user radius is less than 0, therefore if it's a negative number, this if statement will be executed. If it executes, we need to reprompt the user. So now let's insert that while or do while loop. In this case, I'm going to do it with a while loop. To do that, we say while, and then inside of these parentheses, we provide the conditional with our brackets containing everything we want to loop. In this case, I want to loop through everything in the try block. Up here, we need to provide a conditional for the while loop. In this case, I want my while loop to keep going or keep looping as long as there's improper input. So what I'm going to do is create a flag. A flag is another name for a Boolean. In this case, I'm going to call it keep on looping. I'm going to set it to true. I'm going to provide keep on looping into my conditional area. So as long as keep on looping is true, my while loop will never stop. The only time we want it to stop is if we're given correct input, aka a positive number. So we have to ask ourselves, in what part of the if statement do we have a positive number input? Here we said it's any number less than 0. This is negative numbers. So therefore, again, if they enter a negative number, we need to reprompt the user. So we shouldn't set our flag to false here. But below in the else statement, this is where we're given positive numbers. And we know that we're calculating the area and printing out the area, exactly what the user wants to see. So here's where we want to tell the while loop to exit. To do this, we set the flag to false. Keep on looping to false. We don't want to loop anymore. So we say, keep on looping equal to false. And when I set it to false and it re-loops back up to the while loop, it will see that keep on looping has been set to false and break out or finish. So let's go ahead and try this now. First, I'm going to provide a negative number. I'm going to provide another negative number. And we see that it's looping. Now let's provide it a positive number. I'm going to say 100. We see that it provides us our area and then it finishes. Therefore, the looping has stopped. Great, this is what we want to see. Great job, everyone. We finished the entire studio with the bonus missions.